how to use a graduated cylinder in preparation not only for the Discovering Density Lab, but also for the assessment that's coming up about how to use a graduated cylinder. So a graduated cylinder is a glass cylinder which has lines on the side, the graduations, which allow you to measure volume. And so you can see here on the left that there's some liquid. You can see that the line is curved for the liquid, right? And that's called the meniscus. And the reason that the meniscus forms is because the water molecules are attaching themselves to the side of the container. That's called cohesion. Anyway, so what you have to do is you have to measure at the bottom of the liquid. So if your eyeball is here, right, there's my eyeball here, terrible drawing, but it has to be at level. If your eye is somewhere up here or somewhere down here, right, it's wrong. You have to be at the level of the liquid. And it has to be flat on a desk, on a flat surface. You can't hold it in your hand. And this is a zoomed in image over here on the right. And you can see that there's 4 lines in between the 35 and the 40. And each of those lines is 1 milliliter. So you can see that the meniscus is about halfway in between 36 and 37. So you would say that this was 36.5 milliliters. So I want you to make sure that you take measurements like this when you're doing the Discovering Density Lab, and in fact in every lab going forward. So here's the hints for how to read a graduated cylinder. So number 1, you want to make sure the graduated cylinder is on a flat surface. You can't hold it in your hand. Number 2, you want to get at eye level with the meniscus. You can't look at it from above, and you can't look at it from below. You want to put a piece of white paper behind the graduated cylinder. It'll be easier to see the meniscus that way. It'll become a distinct line. And you always want to guess between the lines. So how do you do the Discovering Density Lab? Well, firstly, you're going to take some metal shot, right? So there are these little metal balls. They're going to be sitting in one of the weigh boats, right? It's going to be labeled with a letter. And you want to take 50 or 60 grams of it. So you want to weigh about, you want to tear an empty weigh boat, right? And then you want to pour about 50 or 60 grams, approximately. And then you want to put different amounts of that metal shot into each weigh boat. You want to make it seem like some have more, some have less, etc., right? And they're not all equal to each other. And then you have labeled each of these 1, 2, 3, 4, 5, so that on your data table, you have your samples 1, 2, 3, 4, 5, so you write your masses down according to what the scale says. So it's 2.7 grams, 10.6 grams, 6.7 grams, etc., right? You're going to write all that out. Then you're going to put some water in a graduated cylinder like this, and then you're going to record the initial volume, the volume before you put anything in there. So that's called the VI, the initial volume, and that goes right here. And then you're going to put the metal in. So you have your metal shot in your first weigh boat, and you put it in. Now you have to ask yourself, what's going to happen when you put metal shot into water, right? Firstly, the metal is going to sink to the bottom, right? We learned that that metal is more dense than water, right? In that last activity that we did with the cubes and the cylinders. So, well, let's think about it. If you get in a bathtub like there is one over here on the right, what's going to happen to the water level? Well, you're right. The water level goes up. Well, the water level is going to go up here too. So maybe it's going to go up to about right there, right? So that volume right there is called the VF, the final volume. And then what you do is you put that value right here. Now you're going to think about it. If you put something into the water and the water level went up, how will you figure out the sample volume between, what would you do with these two numbers? Okay? But you're going to try to figure that in class tomorrow. And then you're going to put that value right there. It's the new initial volume. And you're going to take some more. You're going to take some more metal shot from your next container, right? The one that weighed 10.6, and you're going to put that in. And when you do that, the water level will go up again. And you write that new volume right here. And you keep doing this until you fill up the whole page with data, right? It shouldn't take too long. It should take 10 minutes when you know what you're doing. And then you're going to do your calculations for your sample volume. And then you're ready to answer the post-lab questions. So I hope this was helpful. Please make sure you write questions down, and I'll try to answer them tomorrow for you. Thanks. Have a good night.